Hey everyone, welcome back. So today we're going to be solving Leetcode 145. This is actually a series that I'm doing. I've gone through the other two traversal part, that is in order and pre-order. If you want to check that out first, you can go to my past videos and check that out. Today and now we're going to be solving post order. I would highly recommend you to watch those videos before you come here because this is just a continuation of that. Okay. Now again, to treat the same, I have maybe this is a very easy problem. For the ones who know how uh, DFS works or how tree works, but this is a problem which makes you understand how actually recursion is working in a tree, right? So I'm going to be going through the entire stack trees for this problem, and then I'm going to be explaining you guys how it is working in the backend, so that any logic that is related to trees is applied on that particular recursive function, right? So you need to know how the recursive function is being used, and that's exactly what I'm going to be teaching you today. Okay. Yeah, so let's get started. If you already know what post-order traversal is, it's well and good. If not, it's nothing but you're traversing through this tree in the order of left, okay, and then right, and then the node. Okay. Left means the left node, right means the right node, and then node is nothing but the current node that you're at. Okay. This is a code that I've written for post-order traversal, following the same particular direction. It's fairly simple. If you look into these 3 points, it's what I'm doing is I'm going to the left, then I'm going to the right, then I'm printing the value. Here the return type is void. That is the reason I'm printing it. Probably the question is asking us to return a list, I believe. Yeah, that's okay. We can just change the return type, but for now what we're going to do is we're going to print the value, right? So this is exactly the same. First I'm going to the left, then I'm going to the right, then I'm going to the value. Okay. And each of these is a recursive call. I'll tell you why it's a recursive call, and this base condition too, we will discuss about it. This base condition that you see, we'll discuss about that. Okay, so let's get started. So what happens ideally in the background when you call this function from your main function in your stack? What happens is, okay, one more thing is, let me actually name the address. I'll name the address as the same of the value in the node. So 46k, 71k, 53k that you see, these are the values of the these are the addresses of this particular node. Okay, so 73k, 64k, 86k, 20k, 16k, and then 37k. This is to make our solving or visualizing easier. Okay, now post order of 53k would be initially called, which is nothing but my root. Okay, uh, root node. Okay, perfect. Now this would be my parent call. Let me say it as PC. Okay, now I'm going to be calling post order of 53k. Okay, here, so this is nothing but the call that is being made. Now I'm inside the call over here. Okay, so now let's mark these steps. Okay, let's mark this as step 1, step 2, and then step 3. Okay, now after we've done that, perfect. Now let's mark these steps over here. So for each call, how many steps do we have to follow? We have to follow 3 steps, right? We have to follow 3 steps, and I'm going to mark those 3 steps. Okay, so I'm going to mark these steps with 1, 2, and 3. Okay, now what happens is step 1 gets executed. So what happens is pre-order traversal of root dot left is called, right? Root dot left is called. What is the left of 53? It's 46. So I'm going to call post order of 46k. Perfect. Now this also has 3 steps. Again, I'm going to do the same thing. Step 1 is being called now. Okay, this is how your stack is working in the backend. Okay, now again I'm going to be calling post order of 20 post order of 20k. Perfect. Now I'm going to be calling stack again. Not calling, I'm going to be putting this particular frame in the stack. Okay, now I'm going to be calling the first step again, that is nothing but root dot left. Okay, so I'm going to be calling post order of what is towards the left, 16. Okay, perfect. Now I'm going to be calling the first step again from this. Okay, now if you see for 16, does this have any left or right? It doesn't, right? So that is exactly what my base condition is handling, right? For any value which is null, for if the root is null, so what it's going to do is it's just going to return. Since this is a void function, we don't have to return anything, we can just say return. Okay, so now what we're going to be doing, we're going to be calling post order of null. So now what happens is when this post of null is called, it comes over here. Okay, now it checks if the value is null, then it's going to return. So what happens when it returns? This particular stack will get evicted, right? Makes sense. Now once this stack is evicted, my first step is done. Perfect. Now I need to go to the second step. What is my second step? Second step is nothing but root dot right is my second step, right? So I need to call my second step. Let's see if there's any value towards the right. Is any value towards the right? No, there's no value towards the right. So I'll be calling post order of null again, right? Perfect. So again, this will get evicted from my stack and then it'll come down. My second part is done. Now I'm going to the third part. Okay, the third part is nothing but I have to print the value. This is my third part. Okay, that's exactly what I'm going to do. In the output, I'm going to be printing 60. Okay, now the third part is also done. Now what will happen, even this will get evicted out of the stack, because once all these steps are done, this will also get evicted. Perfect. Now let me erase the ones which got evicted, because even stack would be doing the same. So be erasing here. Perfect. Now for me, step one is, so now it comes back to 20k over here. Okay, so for me step one is done. Okay, I have to go to step two, which means I have to go towards the right of this particular stack, right? So what I'll be doing, I'll be calling post order of 37k. Okay, this will also have 3 steps again, right? I'm going to be checking those 3 steps. The first step is to go towards the left of this, which is nothing but null. So I'll be calling post order of null, right? Makes sense. So this will get a vector out of stack, it'll come back over here, right? Now when it comes back over here, my step 1 is done. Okay, what is my step 2? Step 2 is nothing but root dot right? So right is also empty over here. Okay, so what will it call? It'll call post order of null, right? So now what will happen, this will also get evicted from the stack. Perfect. My second step is also done. What is my third step? Third step is to print the value, root dot value. So what I'm going to be doing, I'm going to be printing 37. Okay, now this will get evicted out of the stack, because why? Because 3 steps are over. Okay, now it's going to come back to this, now it's going to see, okay, I was doing the second step, now second step is also over. Now I have to do the third step. Third step is nothing but printing the value, that is nothing but 20k. Perfect. Now this third step is also over. Now what will happen, this will also get evicted out of the stack. Now what will happen is, it'll come to this particular function. Okay, it'll come to this particular function, right? Now what will happen is, in this function the first step is over, right? So I have to process the second step now. Okay, let me erase all this. excuse me. Now what will happen is my second step is what is going on, right? Now what I'll do is I'll be calling post order of 46 of right. Post order of 46 of right is what? Null again. So I'm going to be calling post order of null. So what will happen? This will get evicted from the stack. Now my second step is over. And my third step, I'll be printing 46. Perfect. Now my third step is also over. So this will also get evicted out of the stack. Right? Now what will happen? My first step is over on this. I'm going to the second step. Right? I'm going to the second step. Right? Now in the second step, what will I be doing? Okay? I'll be calling post order of second step. I'll be towards the right, I'll be calling post order of 71k. Okay, this will have 3 steps. Okay, now we'll be processing the first step, which we'll call nothing but post order of left. What is towards the left? 60. What is towards the left? 64 is towards the left. Right? So I'll be calling post order of 64k. Right? So this will also have 3 steps. Right? Yeah. Now what I'll be doing, I'll be calling the first step for this. Let's see if it has any left element. This does not have any left element, and also the right element. So both of them will return post order of null. Right? So what will happen? This will get a vector stack. It'll come here. My first is done. My second is going on. Okay. Now I'll be calling post order of null again. Makes sense? So this will also get a vector stack. Now I'll come back over here. Second step is over. What is my third step? I have to print. 64. Okay, I'm doing that. Now third step is also over. So this will also get a vector out of the stack. Perfect. For 71k, the first step was going on, right? The first step is done. First step is done. Right? Now I have to go to the second step. Let me erase this particular const. Okay. Second step. I'm going to the second step now. Right? Second step is what? Second step is nothing but of right. Second step is nothing but this thing of right. Right? Now what I'll be doing is I'll be calling post order right. This will be nothing but post order of 73k. This will again have 3 steps. Okay. Now first step is going on. Here I'll be calling left. Here I'll be calling left to 73k. Is any element towards the left to 73k? No. Okay. What I'll be doing is I'll be marking it with X. So post order of 73k is nothing but null. So what will happen? This will get a vector out of the stack. My first step is over. Right? Perfect. Now what will happen? My second step will be going on. We have an element towards the right of this particular 73. So what will I do? I will go towards the right. So I'll be calling post order of 86k. Okay, 1, 2, 3. One thing to note is that I'm always calling the address. Okay, not the value, always the address. It is of type node. Okay. Calling step 1, 2, 3. Now 1 will happen. Do we see any element towards the left? No. Do we see any element towards the right? No. So both of them is going to return me null. So post order of, both of them is going to return as the value is null. So I'll be calling post order of null. Perfect. So now what will happen is this will get a vector out of the stack. Now my first call is over. Let me erase this. Next what will happen is again post order of null will be called for the right one, for this particular right one. Okay. So now what will happen is this will also get a vector out of the stack. Now I'll come back. Second one is over. Now the third part is I have to print it. So I'm going to be printing 86. Right? Makes sense. So now what I'm going to do is I'm going to evict this out of stack as my third is also done, as I already printed. Now what's going to happen? It's going to come back over here. Okay, at 73k. Right? 73k. Now the second step got over. Now the third step is going on. Third step is nothing but printing 73. Okay, perfect. Printing 73. Okay, now my third step is also over. Now I'll evict this out of the stack. Perfect. Now for 71k, what is happening? Yeah, for 71k, what was happening? The second step was going on, right? Second step was going on. Now second step, it got over. Second, it came back. Now the third step. Third step is to print 71. Okay, third step also got over. Perfect. Now what I'm gonna do is I'm gonna evict this out of stack. Perfect. Now what is happening? For the 53k one, second step was going on. This is also done. The third step is to print. I'm going to be printing 53k, 53. Not 53k, 53. The value at the end is 53k. Okay, which is nothing but 53. Now third step is also over. What I'm going to be doing, I'm going to be evicting it out of stack. Now, evicting it out of stack. Okay. Now what's going to happen is my recursive function, the recursion function over here, runs successfully. And what happens is it comes back to the function which is called from the main function, right? That is nothing but this one. Okay, now what's going to happen is this also will get evicted out of stack. Okay, now this will be my output. Okay, so let's just validate if this output is correct or not. Okay, for this particular input. So if you see over here, I got 16. Okay, then I got 37, then I got 20, which is correct, then I got 46, which is correct, then I got 64, which is correct, then I got 86, which is correct, then I got 73, which is correct, then I got 71, which is correct, then I got 53. Perfect. Perfect. So we got the answer. Now let's code it. Okay, so what I'm going to be doing, recursion of tree node of node, comma, this integer of final array or final answer. Here I'm going to be writing my base case. Base case is if root, I'll call it root. Okay, naming convention is very important as it gives you a clear understanding on how your solution is being built. Okay, it's null. What I'm going to return is I'm going to be returning final answer. In our case, we didn't return anything because it was type void. Now that we have a type of list integer and because the call also has a type of list integer, I'm going to be returning final answer. Okay, now what I'm going to be doing is I'm going to be calling the recursion of root dot left, comma, final answer. Perfect. Now what I'll be doing is I'll be calling now left is done. I have to call right. Now I'll call recursion of root dot right, comma, final answer. Perfect. Now what I'll do is I'll have to return final answer dot add of root dot value. Perfect. Now I've written this. I just have to initialize the list. Teacher, final list, array list. Okay. What I'm going to be doing is I'm going to be calling recursion of my root, comma, my final list. Perfect. Yeah, looks good. Let me run this. I'm not run the solution actually before. This is my first time, so I might face errors. Cannot find. Oh, sorry. Another class. Okay. Okay. Maybe I can do this. Then I can just return final answer. Oh, I didn't write a return statement. Perfect. Let's submit it. Perfect. Let's look into the complexity. It'll be nothing but of n itself, right? Because you're going through all the elements of the root. Okay. So whatever the value of root is, that will be your time complexity. Okay. I hope you understood the solution. I would suggest you to go through the solution on your own and try solving it on your own. Yeah. So I would. The thing is, you need to understand how the stack is working whenever you're calling a function, right? How the stack trace is happening in the backend. If you do that, your recursion will be easy, and when your recursion is easy, your trees is going to be easy. Okay. Thank you so much for watching.